Hello everyone, this is a quick video on how to find the maximum likelihood estimator for an exponential distribution. For this, we are going to start with the likelihood function, which is very similar to the joint distribution. It's actually going to look almost identical. The big difference between the likelihood function and the joint distribution is in the joint distribution you're typically solving for x, but in the likelihood function we are more interested in theta. Theta is our unknown parameter. So because this is exponential, this is going to be negative x over theta, what we have to work with. This is the equivalent to 1 over theta, exp x to the 1 over theta. This is a negative x sub 1. And 1 over theta times exp to the negative x sub 2 theta, and so on, all the way to the end, where we have negative xn over theta. We can simplify this even further, where you see we have 1 over theta times 1 over theta times 1 over theta, n times. That turns into 1 over theta to the power of n. We also have these exponentials. We can remember our exponent rules. E to the power of a times e to the power of b equals e to the a plus b. So we can use that to simplify. We have negative 1 over theta times the summation from I 1 to n of xi. Now we are going to find we're going to take the natural log of both sides. So ln of L of theta. I'm going to represent this by a curly L of theta. And this is going to change into n to the natural log of 1 minus n to the natural log of theta plus negative theta, the summation from I equals 1 to n of xi. We can see right here that the natural log of 1 is just going to end up being 0. Now, the next thing we want to do is we want to maximize this function. We are finding the maximum likelihood estimator. So we are going to take the derivative of this with respect to theta and set it all equal to 0. So the derivative of this guy right here is going to be negative n theta. The derivative of this guy over here is going to be negative 1 times negative 1 over theta to, this should be a positive, to the second power. And then our summation stays the same. It's treated as if it was a constant. Now that we've set it equal to 0, we can start solving for theta. So we're going to go ahead and bring this negative n over theta to the other side. This is going to change to a positive, so this goes to 1 over theta squared, summation of n x's. We'll times both sides by theta over 2, and this becomes n, and n times theta, summation from I equals 1 to n of all the x's, and theta equals summation of all of our x's over n, which ends up being x bar. And that is our maximum likelihood estimate for the exponential distribution.